Morning to all. Now, so far we have discussed all parts related to the sets except the last part, that is application of sets. Application of a sets. It is application of the sets. 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 What are the application of the sets? You see, A comma B are any two sets. A comma B are any two sets. Then n of A union B is equal to n of A plus n of B minus what? N of A intersection B. So that means what? Diagrammatically you understand this. As you know that rectangle is a universal set. A and B are what? Any two sets. As I already told you that only this particular part is used what? Only this particular part is used A but not B part. This particular part is used what? Not A but B, but this particular part, this is the common part of a two set, is used what? A intersection B. So clearly what you can say here, these three sets, A intersection B complement, A intersection B and A complement intersection B, these three sets are mutually disjoint. They are what? Mutually disjoint. These three sets are mutually disjoint. Means these three sets, you take any two sets, has no common element. Take any two sets, don't have a common element. So if intersection of any two sets has no common elements, then those sets are called as mutually disjoint sets. But what we are observing from here, same. A union B is used what? A intersection B complement union A intersection B union what? A complement intersection B R. But this A intersection B complement union A intersection B is also gives what? Set A or not? This A intersection B, so just what you have to understand here is, from this you clearly observe that, from this you clearly observe that this is the general formula for finding the number of elements in A union B. N of A plus N of B minus N of A intersection B. Why? N of A means this part plus this part or not. N of B means this part plus again this part or not. Now what happened? A intersection B is added how many times here? 2 times. But actually we want to add only 1 time or not. So A intersection B is added how many times here? 2 times. Actually we want to add only 1 time. But we added here 2 times. That's why 1 time I am deleting here. That is N of A intersection B. So this N of A union B, from the Venn diagram we check, it can also be written as what? N of A means this total part, N of A means this total part plus this part or not. What is this part? N of A complement intersection B. But this N of A union B can also be written as what? N of B plus N of B means what? this total part plus this part. That is what? N of A intersection B complement. Like that also you can write this. So these are the formulas related to A. But one the remembering point here is what? If A intersection B is equal to pi, that means what? A comma B are disjoint. Then N of A intersection B is equal to simply N of A plus what? N of B. When, sorry, N of A union B. N of A union B is equal to what? N of A plus N of B. Whenever A intersection B is equal to what? Pi r. A intersection B is equal to pi, then N of A union B is written as what? N of A plus N of B. But if we take, if A comma B comma C are any three sets, if A comma B comma C are any three sets in universal set, A comma B comma C are what? Any three sets, then what is the formula? Then N of A union B union C, same just like this one, but here we have a three sets. So formula is what? N of A plus N of B plus N of C minus what? N of A intersection B minus N of B intersection C minus N of A intersection C plus what? N of A intersection B intersection C. And this is a formula. When A comma B comma C are any three sets, then N of A union B union C is what? N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus what? N of A union intersection B intersection C. But same like this only we can do it, but the only thing is here three sets are there. So here also we can apply the application of this one only. Application of this we can use here. By applying repeatedly this part, N of A union B formula, you will get this result. Repeated application of N of A union B, you will get this result. So how you diagrammatically you should understand this. The diagrammatically means what? By make use of a Venn diagram. Here we have a three set. But this is a set A, this is set B, this is set C. Now just I am giving, see this part, highlighting part you look at here, only this highlighting part is used A but not B and C. This particular part is used what? Not A but B but not C. But this particular part is used what? Not A, not B but C. But this particular part is used. It is A and B and C. But this particular part, only this particular part is used here. It is not A but B and C, this particular part. But this particular part is used what? This particular part, only this particular part. This is A but not B and C. But this particular part is used what? Only this particular part, this particular part is used, arrow mark C, A and B but not C. But this is a commonality of all three sets of them. So it is used A intersection B intersection C. So this is the Venn diagram. So if we asked n of exactly one of a comma b comma c, exactly one of a comma b comma c, exactly one of a comma b comma c is gives what? Exactly one of a comma b comma c means either this one or this one or this one or not. Only these parts, these are only gives exactly one of the a comma b comma c. It is gives what? N of a plus n of b plus n of c minus 2 times of n of a intersection b, n of a intersection b minus 2 times of n of b intersection c minus 2 times of n of a intersection c plus 3 times of n of a intersection b intersection c. That is exactly this, plus 3 times of n of a intersection b intersection c. Means just to add this part. How we get this part? From n of a, you delete a intersection b, a intersection c. Later you add this one. Why? In a intersection b also we are getting a intersection b intersection c. In a intersection c also we are getting a intersection b intersection c. But actually we have to delete only one time. But here we deleted it 2 times. That's why add one time here. N of a intersection b intersection c. Similarly this one also. N of b you delete b intersect a intersection b, b intersection c. But later add a intersection b intersection c. Why we are adding? From n of b you are deleting a intersection b, b intersection c. While deleting a intersection b and b intersection c, in which a intersection b intersection c is also included or not. But actually a intersection b intersection c we have to delete only one time. But here we deleted it 2 times. That's why I added a one time here. Next one, n of exactly 2 of a comma b comma c. That is equal to what? N of a intersection b plus n of b intersection c plus n of c intersection a, c intersection a, n of c intersection a minus what? 3 times of n of a intersection b intersection c. Why? Exactly 2 of means this is exactly a and b, this is exactly b and c, this is exactly a and c are exactly 2 of a comma b comma c is gives what? A and b, only this part a and b, this is b and c, this is what? A and c. But how you get a and b? How you get exactly means this one or not? What is that? A and b but not c. How you get a and b but not c? From a intersection b, you delete a common part of that. How you get b and c but not a? From b and c, you delete a intersection b intersection c or not? Then automatically you get this part. How you get a intersection b complement intersection c? From a and c, you delete a intersection b intersection c or not? So finally, how many times I deleted a intersection b intersection c? 3 times I deleted. That's why I have written minus of this. Right? Okay, now see, the next one is n of at least n of at least n of at least 2 of a comma b comma c. At least 2 of any 2 of a comma b comma c means at least any 2 of a comma b comma c. At least means what? Minimum 2, maximum 3 also possible or not. Total we have how many sets here? A, B, C are 3 sets. But at least 2 set means what does it mean? Either 2 sets or all 3 sets or not. So then what will get it? Exactly to all 3. Exactly to already we know that or not. Exactly to already we know that. To that we have to add exactly 3. Then what happened? You get n of A intersection B plus n of B intersection C plus n of A intersection C minus 2 times of A intersection B intersection C. Ym exactly 2 of A comma B comma C, n of A intersection B, B intersection C, C intersection A minus 3 times or not. That is for exactly 2 of. But here at least 2 means 2 plus all 3 or not. When I added all 3, then what happened? This minus 3 of n of A intersection B intersection C became a minus 2 of A intersection B intersection C. That's it. So this is the related to your sets and sets. Now we'll do the problems on this bottom. What is that? Problem C. Question number 1. A comma B are a 2 set. A comma B are 2 set containing 3 and 6 elements respectively. 6 elements respectively. Then minimum number of elements. Then minimum number of elements. Then minimum number of elements. Then minimum number of elements in A union B. Then minimum number of elements in A union B. Minimum number of elements in A union B. But what is the formula here we'll see. What is n of A union B formula? N of A plus n of B minus what? N of A intersection B. When you get a minimum, when subtracting part is what? Maximum or from this sum. From this, if subtracting part is what? Maximum, then this part is always a minimum or when subtracting part is a maximum, then this part is what? Minimum order. That's why you must know that n of A intersection B minimum value is what and n of A intersection B maximum value is what. This is A intersection B is a minimum whenever A intersection B is equal to what? Phi r. A intersection B is a minimum when A intersection B is what? Phi. Then only we have a number of common elements are less than, that is 0. When A intersection B is a minimum, A intersection B means what? Common elements of A and B. Common elements of A and B minimum when there is no common element or. So in that means what? A and B must be a disjoint, A comma B must be disjoint set. In such a case, number of elements in A intersection B became a what? 0. But when it is a maximum, this A intersection B is a maximum if one set is contained in another set. If one set is contained, contained means subset. If one set is contained in other set, if one set is contained in other set, then we have a maximum or not. So what does it mean? Either A is contained in B or what? B contained in A, then maximum of this is became a what? If A is contained in B, B is a superset or not? Superset means which has a more elements than A. B contained in A, then A is what, amma? A is a superset or not? So that means the minimum of A union B is simply gives what? The minimum of n of A. According to this, minimum is possible when their intersection is a phi. Maximum is possible, A intersection B maximum is possible if one set is contained in another set. For example, A is contained in Bm, then A intersection B is equal to what? A or not? If B is contained in A, then A intersection B is gives what? B or not? So that's why the minimum of n of A union B, what you remember that? The minimum of n of A union B you remember as just maximum of n of A comma n of B. That is only gives you a minimum of A union B or not. Minimum of A union B is gives what? Maximum of n of A comma n of B. But what is the minimum of n of A intersection B is what? 0. But maximum of, here you look at here. Minimum of n of A intersection B is what? 0. But what is the maximum of n of A intersection B is gives minimum of n of A comma n of B. Minimum of what? N of A comma n of B. So you just look at here, how you get this value is minimum when subtracting part is maximum. What is the possibility of maximum of n of A intersection B is gives what? It may be the minimum of n of A comma n of B. Why? If one set is, for example, A is contained in B, then A intersection B is gives what? A smaller set or not? B contained in A, then also A intersection B is gives what? Smaller set or not? So is it or not? So that's why the maximum of n of A intersection B is gives what? Minimum of n of A comma n of B. But the minimum of n of A intersection B is gives what? 0 or not. Next, coming to here, minimum of n of A union B is gives what? Maximum of n of A comma n of B. Minimum of n of A union B is gives maximum of n of A comma n of B. Now you tell here, here is asked, set A has how many elements? 3. Set B has how many elements? 6. But he asked minimum number of elements in A union B. So that's why minimum of n of A union B is equal to what I said, maximum of n of A comma n of B. That is a 6 or no. Similarly, the second question, same concept. A comma B are two sets. A comma B are two sets. So finally, what you get here, minimum of this is A comma B are two sets containing 4 comma 13 elements. Containing 4 comma 13 elements. The maximum number of elements, the maximum number of elements, the maximum number of elements in A union B. I have already told you that the maximum of n of A union B is equal to what? When subtracting part is a minimum, you get a maximum or not? Maximum of n of A union B. So as you know that n of A union B, what is the formula? N of A plus n of B minus n of A intersection B or. So this is became a maximum when subtracting part is what? Minimum or. N of A union B formula n of A plus n of B minus n of A intersection B. Whenever it is a whenever n of A when n of A union B is a maximum, it is a maximum and subtracting part should be a minimum or not. What is the subtracting part here? N of A intersection B. It should be a minimum or not. But its a minimum value of n of A intersection B is what? 0. So minimum of n of A intersection B is what? 0. Therefore, the maximum of n of A union B simply gives what? N of A plus n of B or. Therefore, which is equal to what? N of A is a 4, n of B is a 30, which is equal to 17. Next, the third question, look at here. A survey shows that 63% of Americans 63% of American like cheese, like football, like football. 76% likes basketball. So if X% like both football and basketball, both football and both football and basketball. Both football and basketball. But he asked X value is what? Now here X is what? Here you can take solution of this. You can take X is equal to what? F intersection B, that is football and N of F intersection B. This gives what? N of F intersection B or not? It is N of F intersection B. So now, when I have taken a percentage, you see, now we want to find out the range of N of A intersection B or not. Range of N of A intersection B means what? It's a maximum value and you have to write its minimum value on. As I already told you that its minimum value is what I said, 0. When it is coming to the sets or not, having the elements in the set. But here coming to what? He mentioned that 63% of Americans likes a football, he said. But 76% likes what? Basketball. Adding a football and basketball percentage, we are getting 139% or not. Football is 63, basketball is 76. Total it gives what? 139%. But percentage is only 100. But we got how much is more? 39% is a more or. So that more 39% is gives our least value or not. That is the least possible amount. That is the least possible commonality or not. Least possible commonality is what? 39. Why? By adding the individual percentages, we are getting 139%, which is more than 100%. How much? It's more 39%. So that 39% is a excess on, which may be the commonality of both football and basketball or not. For that reason, I am writing the least one is the 39%. But the maximum possible commonality is what? I already told you that n of A intersection B is a maximum when minimum of these two are not. There is a maximum possible commonality is always gives minimum of those available available twos or not. The maximum of n of A intersection B is the minimum of those individuals A and B. So here the maximum of n of F intersection B is gives minimum of these two or not. What is that minimum of these two? Minimum of 63 comma 76. So finally it is gives what? 39 less than or equal to n of, my n of F intersection B is, take it as what here? X less than or equal to, what is the minimum of 63 comma 76? 60. So this is the possibility of your X, that is from 39 to 63. Right? Okay, Amma. Now see the another question is, fourth question. 2n is used at 2x such that x belongs to natural numbers, and 3n is equal to what? 3x, x belongs to natural number. Then he asked 2n intersection 3n. So 2n is gives what, amma? Even natural numbers. 2n is gives what? Even natural numbers. Why? 2n is consisting in the form of 2x. But what are that x? That x is gives a natural numbers or not. So that is a 2, 4, 6, like this we are getting order. But 3n is what? 3n is also consisting of what? Natural numbers. But what are those? Those are the numbers divisible by 3. That is 3n is used what, amma? Multiples of 3. That is a positive integral. What are that? 3, 6, 9, like this one. But he asked 2n intersection 3n. He asked the commonality of a 2n and 3n. Asked the common elements of a 2n set and 3n set. How you find out that commonality? You can find out that commonality as LCM of 2 comma 3 of n. Now, LCM of what? LCM of 2 comma 3 n, we can write it. LCM of 2 comma 3. But LCM of 2 comma 3 is gives what? 6. So you are getting its answer is what? 6. Whenever he asked the commonality of that, you just find out LCM of those numbers into n. So LCM of those numbers is a 2 comma 3. LCM is 6. So I have written 6n. That's all. Question number 5. X and Y are two sets. X and Y are what? Two sets. Then what is capital X intersection X union Y whole complement? So you want to find out what here? X intersection X union Y whole complement. You need to find this here. For that I am drawing a Venn diagram here. Universal set. Easily we can get it. X union Y, amma. This is X and this is Y. This is X union Y. But he asked X union Y whole complement. Means this part or not. He asked X union Y whole complement. This is the X union Y. Its complement means from universal set you delete this one. Then that shaded region is gives this part or not. This part is gives shaded. But to this part I am taking an intersection with which one? This X or not. I am taking an intersection with which one? This X. So the shaded part and this part has no commonality or not. Shaded part is this one and X is this one. There is no commonality or not. Is there any? Because this is X. X union whole complement means outside of this or not. But this is your set inside. Is there any commonality here? No. So that's why this is gives what? 5 or that is gives 5. Next, similar way, A comma B are two sets. A comma B are two sets. Then A intersection B whole complement. A intersection B whole complement. So you want to find out A intersection B whole complement. So again you draw a Venn diagram here. Universal set. This is A and this is B. So this is A intersection B or not? This is A and this is B. This is A intersection B or not? A intersection B whole complement means what? From universal set you deleted this part or not? Then what is your remaining part? So this is your remaining part on that. Except which one? This one. But this part is commonality with which one? This A or not. This shaded part is commonality with which one? A. So when this is a commonality with A means what is the possibility of commonality? Only at this part or not? This is A intersection B whole complement is whole part. But to that I am taking a commonality with A or not. Commonality with A, what you get? We get only this part or not. Only this part. What is that part? A, but not B. Oh, what is this part, Amma? This part is gives A, but not B or not. A intersection B whole complement means total part except A intersection B. But that part is taking a commonality with which one? A. Then what is left? Only this part is left or not. What is that part? A, but not B. So that is only written here. Question number 7. Two finite sets have have m and n elements. M and n elements. Two finite sets have m and n elements. Total number of subsets of first set. Total number of subsets of first set is 56 more than 56 more than total number of subsets of second set. Total number of subsets of second set. Then values of m comma n. Then values of m comma n. Okay. Then values of m comma n. What is your given to you here? See, let us take that A has a m element and B has a n element. He said that two sets, finite sets have m and n elements. M and n elements. So let us take that this is the first set. This is the second set. Take first set A has a m element, second set A has a n element. What are its number of subsets? Number of subsets. Number of subsets of a first set is 2 power m. Second set is what? 2 power n. So number of subsets is equal to what is the formula? If set A has a n elements, then number of subsets is equal to what? 2 power n. Similarly, set A has a m elements. That's why number of subsets are 2 power m. Set B has a n elements. That's why number of subsets are 2 power n. But how many proper subsets are there means 2 power n minus 1. Improper subset is only a 1, that is a set itself. So remaining are proper subsets. Except a set itself, remaining are proper subsets. Improper subset is only 1, that is a set itself. But what is given to you here? First set has a 56 element. The first set has 56 elements more than the subsets of a second set or not. The number of subsets of a first set is 56 more than the number of subsets of a second set. So that means that the difference of their subsets should equal to what? 56 or not. But here the left hand side everything is in the powers of what here? 2. That's why 56 also writes in the powers of a 2 in this way as a difference. How I write it? 2 power 6 minus 2 cube. Why? 2 power 6 means 64. 2 cube is a 8. 64 minus 8 is what? 56. So therefore, m is equal to 6. N is equal to what? 2. This is the question number 8. Number of elements in n of P of means power set of P of P of P of 5. Number of elements in P of 5. Now P of is nothing but power set. P of is nothing but what? Power set. P of 5 means what is asked to you here? Is asked n of P of 5 is asked to you. That is equal to what you see, Amma. P of 5 means number of power sets of a null set. But as I know that n of A has a n elements, number of elements in power set of A is gives what? Number of its subsets are. Number of its n of A has a n elements. N of P of A is gives what? 2 power n elements are. 2 power n elements. So the number of elements in power set. Power set means what? Power set is a set which has set of all subsets. P of A means power set of A is gives what? Power set of A is a set which contains all the subsets of a given set. All the subsets of a given set. Power set is a set of all subsets of a given set. That's why the number of elements in our power set is equal to number of subsets of a given set or not. So here set is what here? Here set is a null set. It has how many elements? 0 elements. That's why number of power sets are how many here? 2 power 0. Then it became a what? N of P of 2 power 0 is gives what? 1 or not. So now again it is gives what? N of P of. Again this is the power set containing how many elements? 1 element. P of 1 means what? The number of elements in a power set having a single element. If the set has only a one element, the number of subsets of this set is gives what? 2 power 1. 2 power 1 is gives what? 2 or not. That is. Now the last one is what? The number of elements in power sets. This meaning is what? Number of elements in a power set having of a 2 elements. Having of 2 elements is gives what? 2 square. That is equal to what? 4 or not. Simple logic. This is the set having a 0 elements. That's why number of elements in our power set is became a what? 2 power 0 or that. 2 power 0 is what? 1. So that's why this 1 is carrying to next one or that. Now what happened here? Number of elements in a power set. Number of elements in a power set having a single element is gives what? 2 power 1 elements or that. What is the 2 power 1? 2. That's why this whole part is became a what? 2 or that. Now number of elements in a power set having a 2 elements is gives what? 2 square or that is equal to 4. Why? The number of elements in a power set is equivalent to number of subsets of that set or that. Number of elements in a power set is equivalent to number of sets in that set. Okay, ma, you note down these questions, then leave the meeting.